right, so this is the presentation for the Gentex Lift Iteration 2.0. I am Brandon Hayes.
My name is Haider Mansour.
My name is Anthony Last.
My name is Jason Twilliger.
My name is Martez Coleman.
And my name is Alex Banovich.
So the objective of this project was to redesign a Genie lift for Gentex. We were invited out to Gentex by Danny Matash, and we were given the customer needs while we were there. Those customer needs were obviously improvements that needed to be made to this lift. And once we took the customer needs, incorporated them with our improvements, and built this, we were able to configure a final design. Now on to Martez Coleman.
Before we can get started with the project, we first have to divide roles so everyone knew what they were going to be doing. The group leader was assigned to Brandon, so he made sure everyone knew what they were doing and reached out to the customer when we were ready to place orders and everything. Hyder developed the concept design, so he made the different concepts that we're going to be using, and also did the hand calculations to make sure it would actually hold the load that was needed. Anthony and Jason did the CAD design, so they worked to continue to do the FEA reports and to build the concepts that Hyder had designed. Myself and Alex created the bill of materials, and I also did the standards. Okay, so OSHA standard 1910.176 states that you need to be able to have enough room to move the lift through aisles and doorways, make sure it doesn't hit anything. The next standard states that any wiring or cabling that we're going to be using should not be able to be twisted or curled just so it doesn't break and hit anyone. The next standard states that any modified parts that we added on there need to hold at least 125% of the rated load that it's going to be using. And the last standard states that every employee should be trained on how to use the lift. And next on to Jason to discuss stakeholders and customer needs.
So our stakeholders for this project was the Gentex Corporation. They provided their needs and design specifications for the lifts. Gentex was in control of our budget for this project. So these are the customer needs we got meeting with Gentex. The lift needed to be durable, lightweight, stationary, counterweight was very important, stable, had sliders, can support 150 pounds, hands were removable, and the cost of our project was around $1,500. On next to Alex.
So once our customer needs were obtained from our customer, design target specifications were created directly based off these customer needs. And the first column, the needs met column, is what each specification covers in terms of the customer needs. The metric is what exact specification we're trying to meet. The third column, or the fourth column, I'm sorry, is the importance and value based on a 1 through 5 scale, in which each design target specification is how important it is to the customer. The units is just what we're measuring the specification in, and then the target is the range from which the specification we want to meet. So for the design concept selection, we took each design target specification listed in 1 through 8, as you can see in the first column. The second column is their respected importance to the, so the first design target specification had an importance level of 4 based on a 1 through 5 scale, which again was obtained from the customer. Then we took each of our 3 concepts and graded them on a 1 through 5 scale based off how well their designs met each specification, and then took that 1 through 5 grade and multiplied it by that specification's importance value, giving it a total weighted grade. And then from there, you summed up the total weighted grades for each concept, and ours are the total sum, or the highest sum for each of our concepts was concept 3, which 157 points, and then on to Brandon for the proposed design.
As you can see here is a picture of our final concept design number 3, which weighted the highest. The reason that we only have the one picture for our final concept design and not concept design 1 and 2 is due to the reason that we built off each design to make it better and to fit our customer needs at a higher ranking. You can, on the right, you'll see the blow up of the design, labeling what exactly each part is. On to Hader now to talk about the calculations that offered us the ability to create this.
So as force analysis and hand calculation, we have three members. First member is the cross member steel, which is placed horizontally on the lift, have a shear force of 400 pounds and a bending moment of 600 pounds per inch. Second is the arm when it is fully extended and have a shear of 400 pounds and a bending moment of 19,200 pounds per inch. And the third member will be the steel tube, the vertical one, have a shear of 933 pounds and a bending moment of 5,598 pounds per inch. And that from the free body diagram. Then we have to find the worst load location, Q, for each member with a safety factor of 5. The first is the steel tube, and we have a shear force of 385 and a bending strength of 4,522 compared to the actual material, yield strength 46,000 BCI. Second will be the aluminum tube, which is inside the steel tube, have a shear strength of 282 BCI and a bending moment of 16,500 BCI to compare it with yield strength of actual material 35,000 BCI. And the third is the aluminum claw, which is we have the highest load, shear strength of 1600 BCI and a bending moment of 19,600 BCI. To compare it with the material yield strength 35,000 BCI, which shows us that the lift is safe to use.
For the finite element analysis, we use the generative structural analysis workbench with CATIA. For each analysis, we used a max load of 675 pounds. For the aluminum tube, we found that the max displacement was 0.05 inches, and the max stress was 8.33 times 10 to the 4 psi, and the 3 psi. For the steel tube, we found that the max displacement was 0.02 inches, and that the max stress was 2.51 times 10 to the 4 psi. For the claw, we found that the max displacement was 0.01 inches, and that the max stress was 6.64 times 10 to the 3 psi. Now to Alex with the bill of materials.
So as you can notice to the right is our final bill of materials, which included 4 low carbon steel square tubing, 2 6061 aluminum square tubing, 1 6060 aluminum rod, 2 6060 aluminum blocks, 2 zinc galvanized low carbon steel rods, and 1 heavy duty slider, which came to a total of $835.79. However, this does not account for any costs that may have arose from the assembly process, as we were unable to assemble it. So the final cost may be a little bit higher. On to Brandon for the conclusion.
All right, to conclude this presentation today, we created a how-to list that's located within our final report. The how-to list is for Gentex, and that will be a step-by-step on how to correctly build this lift. With all the variables and components needed, it should go smoothly. And we just wanted to say thank you to Gentex as well for giving us the opportunity to apply all of our learned knowledge to a real-world engineering problem. And we hope the best for whoever is building this and for Gentex in the future. Thank you.